Which of the following isomeric dienes is the most stable? So if we're looking at a diene, that would be a molecule with two alkenes. And so the first thing we want to do in evaluating the stability is to look at where those two alkenes are relative to each other. So we see a general stability trend here that tells us that when our double bonds are conjugated, that's more stable than when our double bonds are isolated, which is more stable than when our double bonds are accumulated double bonds. So what we want to do first of all is take a look and see if any of these alkenes are not conjugated. And so if we look at our first structure, we have an alkene here, and then we have an sp3 hybridized carbon that is separating these two alkenes. So there is no resonance here. So these are isolated double bonds. If we look at the second structure, we see this alternating double bond, single bond, double bond pattern. So these are conjugated. If we look at C, we see also that we have a double bond, single bond, double bond. So these are also conjugated. And if we look at D, we have two sp3 hybridized carbons separating those alkenes. So those are definitely isolated as well. So our conjugated double bonds should be the most stable. To differentiate between these, we will fall back on what makes an alkene itself more stable, and that would be substitution. So if we look at the first alkene here, we can see that it has bonds to 1, 2 carbon groups, so that is a di-substituted alkene. And if we look at the end double bond, we see we have only 1 bond to carbon, so that is a mono-substituted alkene. If we look at C, and we look at our first alkene, we see that we have 1, 2, 3 bonds to carbon, so this is tri-substituted. If we look at the second alkene, we see 1, 2, 3 bonds to carbon, so this is also tri-substituted. So our most stable diene should be the one that is conjugated and the most substituted. And so that is C.